I'm going to explain the procedure for experiment of double sideband suppressed carrier modulation and demodulation. Now, as the name indicates, it is kind of amplitude modulation which has double sidebands, but the carrier is suppressed to save the power in the transmitted signal. For this, we need the modulating signal as well as the carrier signal. The modulating signal frequency and amplitude can be adjusted using these two ports. So we'll observe the modulating signal at this point. Then the amplitude of the carrier signal can be adjusted using this port. So we can observe the carrier at this point. We have adjusted the frequency of modulating signal around 1 kilohertz and its amplitude is adjusted around 1 volts, while the amplitude of carrier is adjusted around 2.6 or 2.5 volts and the frequency is fixed at 31.24 kilohertz. We cannot change the frequency of carrier signal. After this, we have applied the carrier signal to the input or FC input of DSB generator circuit and modulating signal to the modulating input of DSB generator circuit. Now I am connecting the probe to the output of DSB generator circuit with the modulated signal carrier is in phase with the original carrier, while during the negative half cycle the carrier in the modulated signal is 180 degree out of phase of the original carrier, and this is how the power in the carrier in the positive half cycle of the modulated signal and the power of the modulated signal during the negative half cycle, which is 180 degree out of phase, will cancel each other and the carrier gets suppressed. Now let's see how the demodulation works. The output of modulated signal is given to the DSB signal input of the DSB demodulator circuit. This is called as coherent detection or coherent demodulation technique, which needs the same carrier used on the transmitter side to be given to the receiver side, so that the demodulated signal will be same as that of the modulating signal. Now if we observe the output of demodulated circuit, we can see output of demodulated circuit can be observed, which is in blue color connected to channel 2, resembles with the original modulating signal. The output consists of some distortions, high frequency distortions, which can be removed by passing this signal through a low pass filter. So for that, we will connect the output of DSB demodulator to the input of low pass filter, and the output of low pass filter can be observed, which is smoother version of the previously demodulated signal. So we can observe that the frequency of modulating signal and demodulated signal are approximately same, that is 1.2 kilohertz, and the amplitudes are 1.22 volts for the demodulated signal and 560 millivolts for the modulating signal. The amplitude of the demodulated signal has increased because we have passed it through the low pass filter, and low pass filter increases the gain of low frequency signals while filtering out the high frequency signals. The channel 2, the DSB output is seen. Now we'll follow the procedure of observing the spectrum. Press FFT. Source is channel 2, window is Hanning, and adjust the highest peak spectrum at the center of the screen and then zoom the spectrum to observe the sidebands. Here we can see that there are only 2 sidebands remaining in the spectrum, that is the carrier has been suppressed. If we compare this with the spectrum of AM signal, that is amplitude modulated signal, then we had seen there were 3 lobes, center lobe for carrier and 2 side lobes for carrier plus modulating frequency and carrier minus modulating frequency, but this in DSB-SC the carrier is suppressed, so we can see there are only two lobes present. One is lower side band and another is upper side band. The procedure for measuring the bandwidth is same. Press cursor, source should be FFT, type should be frequency, and adjust cursor 1 at the peak of lower side band or lower side lobe, and cursor 2 at the center of upper side lobe or upper side band. And then the difference between these two cursor positions is the bandwidth of DSB, that is 2.6 kilohertz. If we remember, the frequency of the modulating signal adjusted was 1.26 kilohertz, and again the bandwidth is double the frequency of modulating signal, which is approximately 2.4 to 2.6 kilohertz, which can be verified using this reading on the spectrum.